Good morning. Today we'll work on sending a transaction. Why is it an option? I don't I don't think it should be an option. Transaction ID is required always. I don't see anything here that says it should be optional. Say cargo build data proto dash p almost. Thursday. My goodness. How's everyone doing? No issues. Okay. I'm just surprised that this is an option. This is the wrong one, isn't it? No, this is data stream, generated data stream. Hmm. Why is it optional? Build modifiers, optional, required. T for scalar types, option otherwise. So we could just say that they are required. Atabasa, how are you? Happy Monday. It's Thursday. Happy Thursday. Let's say that it's required. Interesting. That's required. This one's optional. Database page is repeated. I hear from Tom's stream. Very cool. I like hanging out on Tom's stream. Oh, absolutely. Yeah. We can give a little walkthrough. Let's see. Let's load up the architecture real quick. All right. So let's talk about some basics real quick. The tool I'm using right here is called MonoDraw. It's only available on Mac. Okay. Um, you should get that out of the way real quick. Goals. We want website hosting to be cheap. Right? Well, we want it to be inexpensive. You know, so we need to start from bare bones and work our way up. Right? It needs to be global. Right? People in Australia trying to get to some website hosted in the States should not be penalized. Right? So wherever you are in the world, should be quick to load a website. Not just edge caching, right? Reading from a database, looking at a forum. Okay. Mutations, I'm going to allow for mutations to take a little bit more time, right? Reads, writes must not be awful. Okay. I think we have some plans in place to be able to host the mutations close to where they're happening. Okay. We're favoring read-heavy sites, which arguably is most sites. Even a forum, I believe, is still read-heavy. And I like the idea of having point-in-time DB recovery. Okay, so coming back to our architecture, you have the internet. The internet hits our proxies. There would be some sort of global load balancer. So think, fly.io is redirecting your traffic to the closest node, or nodes, plural, which would hit a proxy. The proxy would be interacting with a cluster management system to figure out, the topology of the system, where the readers are, where the writers are. The proxy would also inspect the request to see, is it a safe request? Safe requests being an HTTP term, and that if it's safe, it's going to the readers. If it's not safe, it's going to the writers. So a writer, let's follow the kind of right flow. The mutation would go to whatever the application is. It could be a forum, it could be a wiki, it could be just some plain old, business card website. Somebody's updating some text on the website. Whatever it is, a mutation happens. The change happens to SQLite on the same box. No network call, no spending milliseconds to hit a nick in order to reach out across a network in an encrypted state and interact with a database that then has to interact with disks and whatnot and send a response. It's all basically in memory and on disk on the local machine. Our VFS, right, being a plugin into SQLite, detects the change, allows the change to go through on a mutation, detects the change, tells data plane about it. Data plane then grabs the change off of disk, sends it to a data archive cluster. Data archive will then fan out the change to all of the other readers. So the change gets fanned out and inserted into all of the other readers to where, if it's a forum, the other people you're chatting with would then be able to see your post. Data archive stores the mutations in TIKV and then possibly a slow storage backup to S3 for very long-term storage. And we're doing the streaming fan out using Iggy. That's pretty much it. We've got, let's say, got the proxy pretty much built out. And I'm say built out in like 80% terms, right? We want to rough this whole thing in, then polish it, and then build something on it, right? Build a website creation software on top of it, etc. So the VFS, I think it's probably about 80% there. Data plane, which exists in both places. This side is about 80%. There's a little bit of update we need to do here because it currently applies the changes directly to a database. It needs to apply them to a wall, a write-ahead log. We are in today. We'll be working on data plane. After it's picked up the data mutation off of disk, it'll be sending it to the data archive server. So that's what we're working on today, this little leg of the journey. What inspired me to take on the project? Great question. So I started this thinking basically I was going to build a website, right? And um, Fly.io has this distributed SQLite thing, right? With some cautions. We're not able to provide support or guidance for this product. Use with caution. It seems like it's slowly going away. Like the adoption wasn't quite there. I'm not exactly sure. I'm not at Fly.io, etc., so I can't really speak to it. But when I saw it, I started to play around with it. I thought it was pretty darn cool. I really like the concept, right? Um, I looked into, how they're doing this, what happens when you have split brain, etc. And I think it's a pretty solid idea. Um, the thing that gave me pause was, where was it? It's this here. They're using a fuse file system. Okay. 100 transactions per second. I want more than that. Right? Because I want to be able to host, let's say, 1,000 or 10,000 sites inside this application. So this isn't going to work for me. So I started to build it out in a performant way. We have half as many writes compared to their implementation. Their implementation is available on GitHub. Superfly. Here it is. LightFS. It's written in Golang. So, and you can see the architecture. I read through their architecture over here, wherever it is, probably in docs. So they write these transaction files, which basically doubles the writes for a database. Now, as we all know, that's the slow part in creating a mutation in the database. Every time you have to go to disk. And if you have to double it and double it, then it's slower. So we avoid that specifically. Um, we support write-ahead logging at the moment and go through a painful process of preserving the write-ahead logs. So a write-ahead log in SQLite is never reused, which is the default. We will preserve it and take that 1 to 2% penalty, because in theory there's like a 1 to 2% speed gain by reusing the write-ahead log, because all of the blocks on disk have been allocated by the OS already, and it doesn't have to do the work of reallocating um, pages on disk. So we have that. We're not using Fuse. We're using Rust with a VFS, and that gives us quite a bit more speed. I suspect that their 100 transactions per second number is low on their website here. I doubt they would put up this number and say, "Oh, this is our beefy boxes" and stuff like that. Like, it's probably not that. It's probably their average box. And I like the idea of how Fly works. Um, so I want to launch my stuff on Fly, which I can't seem to find their infrastructure pages. Um, build a cloud for developers. Pricing. We are in the launch now. Can I just see, learn more? Pay as you infrastructure. Yeah. Yeah, I imagine that, they were probably 100 transactions per second on something simple. And I think it would be nice to be able to have transactions all over the globe with these sorts of kind of lower end boxes scattered all across the globe. And then eventually get to something where you're like running FreeBSD on OVH, OV, something like this. All right. It's not on GitHub. It's actually proprietary at the moment. So I always start out my projects with them not being open, because if there's a chance that I'm going to potentially make a living off of it, I'd prefer to have my options. So, all right, reeling it back in. Sure, let's get rid of that. Okay, we were just looking at this. We're going to require that. It's perfect. So our proto database transaction that we are sending to the data archive server, we're roughing this out. We're going to have a transaction ID. Are we web yet? That guy don't. Happy Thursday. We are nearly Web 2.0. So very close. We need a couple more buzzwords and then we'll be there. So we're going to have our transaction ID, number of repeated database pages. The transaction will be repeated because we will be streaming a transaction. Dealing with protobufs. Yeah, yeah, dealing with protobufs. This is something that we could optimize later if it becomes an issue. I'm really hoping that the act of creating data and sending it is not going to be the choke point in my system. I do think that protobufs and streaming protobufs is cheaper than um, making many HTTP requests. It also, thus far, has been easier to manage the state of the connection separate from making the requests. So that's been nice. All right. So we just put the required tag on this. I did not know that for non-scalar types, the default was option of T. That was new to me. All right, let's come back to database changes. So send transaction is called after we receive a mutation notice. So we are told about the mutation. We sift through the wall logs looking for the data. In fact, I want to extract this out. So we find the wall log, and then we send the transaction. Finding the wall log advances through, like it maintains a bunch of state about the wall log. It takes us to the point on disk. So at this point, we are given the transaction on disk and the connection. Then we'll start reading through it to send the transaction. Part of the state that we manage is knowing what the I change is. This is the number of changes that are happening in the wall log up to this point. So we get the change. That's part of our transaction ID. Transaction ID is not mutable. Frame header. Let's put transaction ID equals. That's the right one. Great. I change salt 1, salt 2. And the salt 1 and 2 come off of the header. And then we can validate that we have this information. Well, that this information is the same for each one of these. Does transaction ID impl partially equal? Yay. Okay. Now, riddle me this. Why Are we not just getting transaction ID from the wall frame itself? Well, we are deconstructing it. We could store it for just a minute. Hmm. So it's really like the wall log itself that has the iChange value. And then the salt1 and salt2 comes from the frame header of the wall log. iChange is not on the wall log. iChange happens to be in the wall index file. It just represents the n number of transactions that have happened inside of the wall log. Send transactions. Snafu. Okay. I'm still thinking about it though, because the wall log, well, it could peek at the frame, right? We are reading data though. We have our reader. No, we would have to wait. We could say that a wall frame has an iChange, something like that, and just populate it. So we read the frame. Yeah, that's our file here. So we also have data structures that represent the wall log itself. So if we do it like that, then we do not need the function there. Let's get this off of the wall frame instead. Let's just get the transaction ID off of the wall log frame, which means we need a frame. Self.iChange. Is this ever used? Why aren't we just calling header? Header's public here. I don't know. I'm going to leave it. Okay. So we have the frame. And this has to be the same for every one of the frames in the transaction. What we're protecting against is uh, file not having been written or a transaction. Yes, basically the same thing. Uh, Data not have been completely written to disk, right? This could also protect us from ourselves. So, kind of a belt and suspenders approach. We want to make sure that we don't overrun the transaction, right? Go past the end of it and send too much data. And that data might actually be stale data from a failed transaction before, because SQLite will write ahead in the wall log. And if it needs to abort, it just moves the write head back, right, to the beginning of the transaction and uses the space again. So need to make sure that's the same. And then we're looking for a commit record. Right? When the commit record exists, then the transaction's done. Oh, thank you. Transaction. Zakiton. Transacaton. Uh, I don't always read what I write. Thank you. Let's get rid of the iChange value. We don't need that. That's gone, right? Yep. We have our pages and our commit record. This will be mutable. Commit record mutable. And our pages should start with the data from this frame. Then we will add n number more frames to send and continue. I feel like I'm still getting this wrong. It feels partly right. So TX is database transaction. Basically need to do this part here in a loop. So this is this could probably just be like a for loop here. Pages. Trunking the transaction. Basically something like so. We loop until the transaction is done. And we have a commit record. Send. This piece actually has to go up at the top. Okay. So we create our channel. I hit tab or something. I don't know why I did that. Um, Set up the stream transaction. So we go to record our transactions. It almost feels like this should be done before, like outside of this. Like we are recording many transactions. We're just going to keep streaming them as they're happening. And whenever we find a transaction, we just send another. This, yeah, this isn't right. We should just be passing in our TX here that we send our transaction on. Okay, let's move that up and out. Now, TX in this case is unbound sender of database transaction. Great. Oh, each time one of these pops up into chat, end up reporting it. And Twitch later sends me a very nice email. There we go. All right. Sender. And this was a database transaction. We want the one from data stream. It actually changes later on the other end. Slightly different. And it's okay. We evaluated that in one of the previous streams. Okay. So we have our TX. Send the transaction. So we get the first frame to set up. We need to store the page of the first frame. Whack a spam bot. Yeah. Set up the transaction. We also have the possibility that the first page is the only page. While it is none. There, we could do that. I almost feel like we should have some. I want a new type here. Database transaction is nice. And we could probably do like a frame dot into transaction. And then like a append frame. Which I like. I like them much more. This would be mutable. How would I do that? So we have our transaction, which I don't think we really need because we should be sending the message, but message is a transaction. I set this up funny. Okay, I'm going to ignore this stuff in here for a minute. So we want our transaction. And happy Thursday, Xenocron. Frame.into. We need to generate that code. That code doesn't exist. But it's not complaining about it. Mismatched type. My LSP is not having a good Thursday. Let's give it a bump. Okay, so database transaction is actually part of the generated proto code. So we will implement this on the frame. Next to the frame, rather. We have a wall frame. Impl. From for database transaction. We want the stream variant. Pages. And this, I think, is a single page at the moment. Value dot set data. And the commit record. What did that look like? It was an optional thing. DB page count. That's right. But we only want this if there is a DB page count. So let's say self dot header. Don't we have header on wall frame? Oh, self is not correct. It's value. Value dot header. The page count, page number isn't it? It's actually is commitment record to DB pages here. I kind of want like an option here. Or we just say commit record. Change this into a commit record. But then this crate has to know about the other crate and dogs and cats living together. All that. Ghostbusters, right? Um, just match here. So if it's 0, we get a none. If it's anything else, and this is the wrong function, TV pages. There we go. Expected option found. Process didn't exit successfully. Required fields are not allowed in Proto 3. Oh, boo hoo. Nope, not the generated code. Stream. So we're not allowed to say this is required anymore. That's a bummer. I did not read it that way. I get that it's here. Like, this is a valid modifier. It doesn't say it's not a valid modifier for 3. So, yeah, weird. Do you know what the rationale is? The default representation for all user-defined message types is option type T. For scalar types, just T. During decoding, a missing value is populated by default. If you need a witness in the presence of a scalar type, use the optional modifier to enforce an option. Okay. It doesn't talk about. All right. Oh, you can do one better and pull up a GitHub issue. That would be interesting. Find variant, data string, mismatched types. Expected database page. Vector, okay. What is a database page? I don't remember anymore. Oh, right. Forgot about that. All right, page number, all that. We have to get from the frame header. So this is database page, should be used down below. Page number. Ooh, the checksum. We'll get back to that. Value dot data. I feel like I should break up the wall frame. If you recall correctly, the TLDR was that required results in non-obvious backwards compatibility issues. Adding a required field causes messages generated by older implementations to not be forward compatible. Okay. So in the case that you already had something in production and you added something new, then the older ones wouldn't be able to be compatible. Maybe it's just my seasoning here, but I've it feels obvious to me that that's a backwards compatibility issue. Take the data, start database checksum. Oh, right. I can't actually do this here. Yeah, it makes sense. Yeah. The older producer would produce a message without that required field. The newer consumer would not find the required field and consider the message invalid, which I think is correct. Yeah, I don't agree with not allowing it. These sorts of bookends should be allowed. Okay. Yeah, we're going to move this. Where shall we move it to, though? You know, we don't have here. That's the database page info. Yeah, I'm going to just dump this down here for a moment. Let's pipe that database info through, then we'll get to this. Go ahead and delete here. So we have our handy dandy database checksum. So this guy here, it's clonable. It has a dash map, which is awesome. So we would need to basically look up the database in here and twiddle some bits. Okay. So let's pass this through. AppDB checksum. Where was that? Here. AppDB-dir. Pass that through. It probably makes sense, considering that protobuf doesn't give you an out-of-the-box solution for versioning your messages. Or rather, they just expect you to have one message and add or remove the fields from it over time. Marking deprecated fields IDs as reserved. Yeah. And it works. I mean, it's Google, right? So probably backing a lot of data, backed by a lot of data. We avoid n number of bugs per year by this. Right? Is that on there? Okay. Yep. Update DB checksums. So this is getting closer. Good, good. So DB mutation receiver, we get a mutation, and a DB mutation looks like what? Go to the type this way. No, no, not that way. Mutation receiver. There we go. Has the file salt1, salt2, position and length. So we actually have to get the file name to look up the bit from the database mutation. So we find the wall log. Now wall log, it has a buff reader, but it doesn't have. You know, it would be kind of fun if the wall logs had one of the DBs associated with it, so we wouldn't have to look it up all the time. To be honest, if you work in non-null safe languages, you won't even notice. Yeah. Oh, yes. I actually like the idea of the wall files having this thing because the wall files basically knows the path to a file. So when one of these things is getting looked up, we could associate that database, that checksum database with a wall log. It's a dash map. We can keep a reference. I think. Can we keep a, or is there something special we'd have to do? Let's look, docs and RS. Dash map. So we'd have a ref. The ref would have a lifetime, so we'd have to introduce a lifetime, which we don't have. But it would work because our files, wall files object, would live for a shorter period of time than the other. Cool. All right. Checking the phone. All right. Reader. Da, da, da. We need a copy of our file path. And I don't like this. I don't like having to look it up all the time. I would much rather keep that reference. If this was C, store the pointer to the thing. See, well, files could hold a reference to the database stuff, right? App DB checksum could hold that. Oh, it's not DB mutation. It's a DB checksum. So we could hold on to that. But then when we hand these out, this wall log here will be a reference to a wall log, basically a reference, immutable reference to something here. Seems doable. Let's try it. Let's see what sort of trouble we can get into. Okay. Where does this get called? Great. AppDB checksum. Passing that through. I'm done. Okay. Now, whenever we're creating a wall log entry, we need to give it a little bit extra. We'll have a lifetime to a DB. Let's call it checksum DB. DB checksum, 1 : DB. It's not this. No, it's not that. This is supposed to be a dash map reference. Oh, I don't have dash map available for this crate. Ooh, a leaky interface. Let's leave that for a moment. Maybe checksum. Add database. Checksum DBs. DB list. Okay, no. This here. We could make that some sort of type. See, this isn't what we want either. Because I believe if we get mutable, may deadlock if called when holding any sort of reference into the map. Hmm. Okay. So maybe this won't work. Because we'd have to hold on to a mutable reference. So we need whatever it is to look this up. Fine, fine, fine. And we are looking up the path. Which means we can get rid of a lifetime. And I wish there was a better way to get that. I'm going to stare at this code over here for a moment. DBs, we have the base pass and the checksum. They could hold a reference to the dash map with their file name and just look themselves up. And it's possible. Add data, let's see. And then get mutable database, checksum, get mute. Relative DB. So in this case, it's supposed to be relative. They're not going to know if they're relative or not. Yeah, we'll have to change this to take that into account. Or we'll have to generate them, make them relative. Okay. Something like so. And then DB checksum. I don't like that name, by the way. It's just the only one that kind of stuck. So that a log can return. Something like so. Have that. And whenever we create one of these, provide the relative path so it can be looked up. So I think we get the same relative path elsewhere. All right. So we get our path. This is the full path, not the relative path. Does appdb checksum provide access to it? Get base path, it does. Okay, perfect. Eventually, I'll have a better name for this and check some DBs. Why not? Now, the other thing we need is that relative path. It might be off of path. Is relative. I want to make relative parent. Strip prefix. Ah, there we go. So we strip the base off of the element. Strip prefix. With context. What kind of error is this? This is a wall log prefix. Say wall log file prefix. No. Good. Let's create one of these. I don't remember what the source was. Get back to that. And what was our source? The source is, see, a strip prefix IO. I'm guessing IO strip prefix error. Huh, standard path strip prefix error. Hmm. Path buff doesn't implement display. There we go. That's not where we were. Oh, my jump list is foobarred. Um, we were here. AppDB checksum. Let's rename that. Checksum DBs. Relative path. Was it relative DB path? Hmm. Oh, and this is for the wall log. We also have to change. Wow. Okay. We need to strip the dash WAL off the end. Hmm. Okay. File name. Mount. We have in here make ASCII try clone. Yeah, this Illustrator doesn't have much, does it? Okay. The trait bound as ref. Okay. Oh, this only works if it's something. Okay. Yeah. We'll pour some more water. Okay. Let me code. Good afternoon. Happy Thursday. Okay. But this isn't correct. What do we want to do here? We have to convert it to something else to make it useful. Because OS stir isn't all that interesting. Let's on Unix. Let's see. From vec into vec. That's interesting. We could convert it into a vector and then change the underlying data, which is interesting. Surprised this isn't running an error. Okay. Let's try it with the vector bits. So 2vec. Where's our list or ext? Unix, FFI. Oh, as bytes and from bytes. A string isn't UTF. Oh, okay. Got it. So at this point, we want to find dash wall. Um, Finds. Now this being slice. I know how we can do this with iterator. I'm not as familiar with slice. If there's any looking for an offset and index. Element, oh, nightly only. Okay. Yeah. Strip suffix. I don't know exactly what the suffix is going to be though, because it could be dash wall or it could be a salted wall log. Right? Where these are numbers. Do an iter with a window. If you can get a stir and then find works. Yeah, I was trying to avoid the conversion to and from string just for fun. Excuse me, I'm trying to find 1 or 2 bytes. Chunk vectored. Interesting. Hmm. What does memchar do? Is it basically looking for? Actually, we want to start at the end of the string and see if it ends in dash WAL. It does a nonlinear search for a needle in a haystack. So I kind of want oh 1 or 2 bytes using SIMD. It's an external crate by Barsushi. Huh. I was thinking, I want a window, don't I? Array windows. Nightly only. Wait, what did that say? Batch slice. Oh, interesting. Yeah. Oh, that's interesting. It's kind of fun. I like that window will deal with the kind of edge cases towards the end for me. Um, is there like a reverse window? And then do split out in a loop with more slugs. Right, I've got 5 minutes. Let's play. Um, so basically, we wanted a reverse search. You just do dot rev to really? Oh, because it's a double-ended iterator. Ew, that feels very rusty. Windows. We want a size of 4. Rev. Or next. Now, for this, I would need to keep track of the position myself. Position, and our predicate would be, yeah, slice. Is it B for bytes? How do you do that? Yeah. Instead of the rev, I get it. Oh, okay. I wonder what this compiles down into. Iterator are whatever methods go backwards. They are double-ended iterator, which is really nice. Okay. So in this case, we will return DB file name will be bytes 0 dot dot pause. Oh, found an option. Huh. Unwrap or the default for this is bytes dot length. So we don't have that at all, then we use the whole thing. And DB file name, it's an option. They always have file names. Oh, I forgot to go back to from bytes. We did as bytes. From bytes. I would definitely write a little test for this. I'm not sure how the iterator is simpled on Windows in that regard. Huh. Interesting. All right. I'll do that. Um, this is interesting in that in this case, Do we just call this on the trait? Ah, yes. We'll check that in a moment. How do we go from bytes? Is this on OSter? Doesn't seem to be. Oh, maybe I just didn't have it imported. Okay. I already imported the ext trait, extension trait for this. Okay. Looks like it's there now. Have curiosity. So our position. Must be a string literal or oh yes. Someone. So it did find it at position 1. Oh, command enter. Really? Oh, look at that. That's cool. Oh, and control enter. That's just a Firefox thing. 6. Yep, that's right. As of Rust 1.85, default is now Rust 2024. All right. But you're right. This could use some more tests. All right. But I do have to go. Need to herd some cats and pay the bills. I wasn't sure, and sometimes it's not obvious. Yeah. Well, it's always good to check that. Okay. That looks all right. You can see it reversing the byte order. Oh, I see. Yeah, yeah. That makes sense. Well, thank you all for hanging out. It's been fun. We'll see you all tomorrow. Take care. Bye bye.